Hello everyone. Have you ever wondered that how scientists measure the concentration of a solution? Well, all credit goes to the Beer-Lambert Law. So let's dive deep into the concept of Beer-Lambert Law. Beer-Lambert Law explains how the light interacts with the solution. It states that the amount of light absorbed is directly proportional to the concentration of a solution and the path length of light, either by increasing the concentration of a solution or by increasing the path length of a light. The amount of light absorbed also increases. Let's see the mathematical relationship of the Beer-Lambert law. This is the mathematical relationship of the Beer-Lambert law, where A equals to EBC. A is the absorbance, E equals to the molar absorptivity or the proportionality constant. B is the path length in centimeter, while C is the concentration in mole per liter. As you clearly see in the expression, that by increasing either the concentration or path length of light, the absorbed light also increases. So let's understand the Beer-Lambert law with the help of animation. First, let's make the solution in 500 ml of KMnO4 to measure its absorbance depending on its concentration. First, fill the beaker with the water up to 500 ml. So this is the 500 ml of water. Now add the specific amount of KMnO4 in it to make its aqueous solution. So this is the aqueous solution of KMnO4. Now let's understand, or let's see its behavior under the presence of light. Okay. So first we will select the solution of KMnO4. Okay. Now first this is the light source. This is the sample cell or the cuvette where we place our solution, and this is the detector which detects the absorbance of light or the transmitted light. So first we will on the lamp, okay, and see the transmittance of light. The concentration, depending on the concentration of solution, the light is absorbed from the light source. If we increase the concentration, let's see by increasing the concentration what will be the effect on the absorbance of light. If we increase the concentration of solution, we see the absorbance increase and the transmitted light decrease. You can see the transmitted light is getting dim because the transmittance decrease. You can also see the transmittance in the transmittance meter. So the transmittance decrease by increasing the concentration of a solution. As we will increase the more concentration, the transmittance is decreased. As we decrease the concentration of a solution, the transmittance will increase. So this basically explained by the Beer-Lambert law. Is the simple concept, and but very helpful in many applications. In checking the quality of a water, that how much concentration of pollutants remain in a water, and there are a lot of other applications where the Beer-Lambert law is used to measure the specific amount of light absorbed by the solution. So that's all about. Thank you so much.